In this video, we'll be doing an example applying the mean value theorem. So remember what the mean value theorem tells us. It tells us that if you have a continuous function on a closed interval AB and differentiable on the open interval AB, then we know that the slope of the secant line connecting the point from A to B, so f of B minus f of A over B minus A is equal to the derivative of the function at some C, where C lies between the interval A to B. So that is the conclusion of the mean value theorem. Now we're going to use this for this example. Suppose that 3 less than or equal to f prime of x less than or equal to 5. So this is our condition on the derivative for all x. What are the minimum and maximum possible values of f of 7 minus f of 3? So the interval we're looking at is from 3 to 7. So the interval, as you can see it from this problem, is considered from 3 to 7. So this is like your A value. This is like your B value. Now, but we want to know what is the bound for this difference. In other words, we want to know what is the lower bound. So we want to know what is the value that is less than or equal to f of 7 minus f of 3 that is less than or equal to some number. So we're trying to figure out what's the lower bound, that will be the minimum, and the maximum for this difference. So let's go ahead and set up the mean value theorem. So we're going to go ahead and set this up. So we know that our f of 7 minus f of 3 over 7 minus 3, because that's your B minus A, this is equal to the derivative of f at some C. Then let's go ahead and simplify the denominator. So we know the denominator of this will simply be f of 7 minus f of 3 over 4 is equal to the derivative of f at some C. And then we multiply both sides by 4. So this will give us f of 7 minus f of 3 should equal to 4 times the derivative of the function. All right, so hold on to this. So we got this statement right here. Now we're given the statement that the derivative lies between these two values. So let's go ahead and write that down. Derivative for all x. So I'm going to replace x with c. So we know that now, since we know that the derivative at any c is always between 3 to 5. That was the interval we're given. Now we know that the derivative at some c times 4 must be equal to that. Well, if I want this to match that, I will have to multiply each side of this equation, inequality, by 4. Then I'm going to go ahead and write this. So we know 4 times the derivative of f at c must be greater than 3 times 4 and must be less than 5 times 4. So I just want to match this statement right here. All right, now if I finish up the calculation, I know this is going to be 12 less than or equal to 4 times f prime of c less than or equal to 20. Well, what is 4 times the derivative of c? Well, that is f of 7 minus f of 3. So let's substitute that right here. So you're going to get your f of 7 minus f of 3. This must be less than or equal to 20 and greater than 12. So these are the bound. That's the minimum value for this difference, and that's the maximum value satisfying the given condition. All right, I hope this makes sense. Take care, everyone.